Hi guys, and welcome to your next video lecture. Today we're going to be discussing the notes for section 7.4, which happens to be the last section in chapter 7. So we are gearing up for a test this Friday, immediately after the live session, as I may have mentioned in our previous video lecture. But just to be sure, a little housekeeping. Today, this is going to be section 7.4. It's the last section in chapter 7. So on Friday, immediately after our live session, which we're going to use to make sure that everybody's on the same page, that we're all caught up, that we can discuss any issues with turning in work through the digital platform of Blackboard. We'll get all that cleared and out of the way, make sure that you have the opportunity to ask any questions and review any types of problems that you may have had some difficulty with. And then the live test will become live after we've completed our live session, probably within the hour of the completion, and you will be given exactly 2 hours to have the test completed and turned in before the weekend. So that's the plan there as far as our live session on Friday. And then also wanted to let you know that currently our final exam schedule is remaining the same as was announced at the beginning of the semester. So our final exam for this course is scheduled for Friday, May 1st from 11 to 1:30 p.m. Now, because we cannot take up that entirety of the portion as a live session due to conflict with other classes that also have live sessions on a Friday, what we're going to do is you will have from 11 to 1:30 p.m. to complete the test. The test will go live shortly before 11 a.m. on Friday, May 1st, and it will stay live until 1:30 p.m. on Friday, May 1st. Then it will close. And you will have to make sure during the time that you submit your exam that I have received it and that I can open your document and that it has been successfully submitted, since we are obviously not going to be able to meet live on that day for the entirety of the session. Now, we do have from 1 to 2 scheduled for us, since that's when we always have a live session. So from 1 to 2, I will log on live, and you can feel free to do so as well. One, so that you can ask questions as far as any question you may have in understanding what a particular question is asking of you during the final. And two, if you want to live speak with me and make sure that you have submitted your test successfully before we log off and you don't have an opportunity to speak to me anymore, since at that point we will no longer see each other because effectively our time together for the semester will be over. All right. That's enough housekeeping. If you've got any questions, feel free to ask me via email. We're going to go ahead and move on to our notes for section 7.4 today. So let me go ahead and start sharing my screen so that you can see those notes and we can discuss them. I'm going to get rid of this over here and cancel that. All right, and then we're going to full screen this here for you. And we're going to zoom this in. All right, so our final section in chapter 7 is on percentages. So in chapter 7, we talked about fractions, then we talked about decimals, we talked about operations with decimals, and now we're moving on to percents, which is very much connected to fractions and decimals, as well as our conversation on ratios that we discussed. So we're going to start off by talking about how we convert percents. Okay, so, and we're going to be talking about converting percents to fractions and to decimals, and also we're going to be discussing how we convert decimals into fractions and fractions into percents. So basically we're going to be going forwards and backwards across this conversion line here that you see highlighted in pink. Now, why are we talking about percents? Well, that's because, like ratios, percents are used and seen in common everyday life. It is something that you should be able to work with. If you want to know how much tax you're going to pay on something you're getting ready to purchase it, you need to know about percents. If you want to know how much tip to leave at the end of a meal, you need to know about percents. If you want to know how much money you're getting in your raise, you need to understand percents. Information is constantly disseminated to us as consumers in percentages, so it's important for you to know how to work with them. Now, the reason why information is given to us in percents is because We can, in percent form, represent ratios, fractions, decimals. So it's a very useful form of representing these things which are around us all the time and are useful for giving information. Now, percent in and of itself, the word percent means per hundred in Latin. So its name is very directly connected to exactly what it is. So 25% is 25 out of 100, or 25 per 100, which, if you recall from our conversation on how to convert base 10 fractions, we can convert that into a decimal very easily because we count the number of zeros. We have 2. We put our decimal point at the right of our numerator, which is where it always is in any whole number situation. And then we move it to the left 2 places because there are 2 zeros in our numerator. So we get the decimal 0.25. And you can see that we can do the same thing with 420%. This is still, because it is percent, we're still talking out of 100. So this is 420 out of 100, or per 100. Because there are still 2 zeros in our denominator, we will still take our decimal from our numerator and move it 2 places to the left, giving us 4.2. which is the decimal representation of 420%. So in general, we think of percent as so much out of 100, okay? Pretty straightforward, no confusion there. Now, oh, sorry, let's get back here. What happened here? Oops, sorry. I, didn't touch it. I've got a very sensitive computer here, and it seems to be having a little issue. Let me pause you for 1 second, and I'm going to fix that, okay? Okay, we have fixed that problem. My apologies for the quick little glitch that we had there, but we are all set now, and we're going to go ahead and open those notes, and we should be fine. So we had left off here. So now we're going to talk about how we're going to convert from a percent into a fraction, okay? And simply how we do that is that we use the meaning of the word percent, meaning that, as I mentioned earlier, percent is defined as something out of 100. So how do we convert a percentage into a fraction? We simply say, well, this is 63%, so that's 63 out of 100. Boom, we're in fractional form. And if necessary, or if possible, you could simplify that. But there you go. That's how we go from percent to fraction. Pretty simple, pretty straightforward, no real complication there. Now, how do we go from percent to decimal? Well, the hint that you're given here is convert to a fraction first, and then go to a decimal, because we already know how to convert fractions into decimals, both if they're base 10 denominators, like when they're out of 100, or out of 10, or out of 1,000, or if it's not a base 10 denominator, we know how to convert any fraction into a decimal simply by treating the fraction as a division problem and dividing from top to bottom, or numerator divided by denominator. So to convert a percent into a decimal, we take 63% and we turn it into a fraction, just like we did in part A. And once it's in a fraction, and because it is out of 100, it is a base 10 denominator, we can either one, put it into your calculator and do 63 divided by 100, and boom, it will tell you 0.63. Or you can remember that because your denominator has 2 zeros, our decimal point is right here to the right of 63, and it goes to the left 2 places, and you get 0.63. Either way is fine. Remembering, excuse me, there seems to be something in my eye here. Apologies. Either way, either remembering that the 2 zeros make you move that decimal point 2 places to the left, and so you can do it using quote unquote mental math, or you can just pop it into your calculator and remember that fractions are division problems from top to bottom, 63 divided by 100. Either way, you get the 0.63 as your decimal. Now, how do we go from decimals to percentages? And the hint you're given here is that you just reverse the process that we just used in part B to go from percents into decimals, right? So we're in essence going backwards. Now we're going from decimals to percents, right? Now there are 3 ways you can do this. I am showing you all 3. You can choose whichever one you find most comfortable and use that one and have it work for you every time. Now, 1 and 2 are in essence the same method. It's just accounting for the difference in what happens to your fraction form. So we're going to go ahead and take 0.63 and turn it into its fraction form of 63 out of 100. And because it's already out of 100, turning it into a percent is easy. It's already out of 100, so it's 63%. Okay? But what if you had 6.3 as the decimal you started with, and you turned that into a fraction? 6.3 as a fraction, if you recall from our conversation of decimals to fractions, you take that decimal point from where it is, and you move it all the way over to the right so that you can now have a whole number to use as your numerator. And you use that 63 as your numerator. And then the number of places you move to the right is the number of zeros you give to your base 10 decimal, your base 10 denominator. So because I moved it only one time over to the right, my denominator is 10. Well, that's not out of 100, and I'm looking to convert into a percent. But that's easy because I do have a base 10 denominator, so I simply have to multiply it by whatever power of 10 is necessary to get me to 100. Since I'm at 10, I just need to multiply by 10. But obviously, rules of fractions, whatever you do to the bottom, you must do the top, and vice versa. So we multiply both top and bottom by 10, and now I have 630 out of 100. And that indeed is how I can get to my percent. 630 out of 100 means it's 630%. And 6.3, when converted to percent, is just that, 630%. Okay? Or last but not least, if you wish to go the easy route, which is the route that I find the easiest to work with when converting decimals into percents, is to simply take your decimal and multiply by 100. So 0.63 times 100, 630%. Okay, so this number 3 would be my personal favorite option for how to deal with converting a decimal into a percent, but we've given you these other options here so that you can use whichever one works best for you. Finally, we want to discuss how do we convert fractions to percents. Easy. The hint is take your fraction, divide it from top to bottom, as you just heard me discuss just a few seconds ago, and then get your decimal and multiply times 100, like I did here in method 3 when we were talking about converting decimals into percentages. So let's look at some examples so that you can see what we're talking about. For example, if I'm given 3 divided by 13, right, or 3/13, I go ahead and put that into my calculator as 3 divided by 13. My calculator tells me that that is the decimal 0.23. I go ahead and multiply that times 100, and I've now converted the decimal version of my fraction, 0.23, into a percent, 23%. And so it turns out that 3 out of 13 is indeed 23% of 13. Okay? Second example, and this is because sometimes when you go ahead and take a fraction and convert it to decimal, you have a non-terminating decimal, as we discussed earlier in this chapter. So if I have 5/9 and I want to turn that into a percent, I go ahead and go 5 divided by 9. If you put that into your calculator, you'll get 0.55555 until your calculator can go no further. So this is obviously a non-terminating decimal. How do I turn that into a percent? Well, you round to the hundredths place, because remember, we're looking to turn it into a percent. That means out of 100. So you round to the hundredths place, and 0.555 would be rounded to the hundredths place 0.56. And then I go ahead and multiply times 100 to get my percent, 56%. So 5/9 is approximately 56%. But because we didn't have to round off, it's why we usually in math circles talk about fractions as being the exact answer. And once we move into decimals or percentages, we are saying that we are close to the exact answer, but it is still not exact. All right. Now, some things that we can do with decimals is that because we can estimate percentages using fractions to help us do so, because there are some fractions that have common and convenient there are some percentages, as you can see here, that have common and convenient fraction equivalents. For example, 25% is always 1/4, or 1 out of 4. 5% is always 1 out of 20. 50% is 1 out of 2, or half. 10% is 1/10, 75% is 3/4, 33 and a third% is 1/3, and 66 and 2/3% is 2/3. So these are pretty easy to memorize, and you run into them a lot. And when you remember these very convenient fraction equivalents of these percentages, then estimating becomes pretty easy, and you can actually do it in what they like to call in Common Core here in New York using mental math. So for example, if I'm given what is 25% of 44, I think to myself, oh, well, 25% is 1/4. So 1/4 of 44, and you can think of it as multiplying fractions, is really 11. So 25% of 44 is about 11, okay? And then another scenario, and this is where the fact that multiplication is commutative and we have the commutative property of multiplication becomes very useful. We have what is 38% of 50? Well, 38% of 50 is the same thing as saying 50% of 38, right? Because multiplication is commutative. So that's what we do. Instead of doing 38% of 50, we say, well, what is 50% of 38? Why? Because I have a very easy fractional equivalent that I can pop into my head and get this answer easily. And so 50% of 38 is the same thing as saying half of 38. So that's about 19. So 38% of 50 is about 19, or 50% of 38 is about 19, okay? All right, so now that we have these percent skills where we can convert from fractions to decimals to percentages and vice versa, and we know how to do some very easy rounding using those convenient fractional equivalents to some very common percentages, we can get some applications to our percentages, which is solving percent problems, okay? And there are 3 ways of doing this. There are 3 methods that I'm going to walk you through. But basically, for all 3 methods, you have to be aware of the fact that since percentages can be expressed as fractions, percent problems always involve 3 pieces of information: the percent, and then the part, which is the numerator of a fraction, and the whole, which is the denominator of a fraction. So all of our percent problems will always address the need for these 3 parts, okay? Now, the first method we have is where we use what's called the percent equation approach. This equation is extremely useful, and I strongly recommend that you memorize it. This is what we call the percent equation. The percent equation says that a percent, a being any percent, times the whole of what you're talking about is equal to the part represented by that percent. Now, please note that this equation, because it is an equation, can be manipulated depending on what pieces you have so that and what parts you know. So for example, if I have the whole and I know the part, but I don't know what percentage that part represents, I can use this equation to solve for that percentage. Or if I have the percentage and I have the part, but I don't know what whole that percent took this part out of, I can go ahead and manipulate this equation to solve for that whole, as you're going to see in some of the examples we're going to look at now. So using method 1, which is the percent equation, we're going to solve these 3 problems, okay? Problem number 1. You're going to purchase a car for $13,000. And the dealership requires that you put a 20% down payment in order to purchase the vehicle. The question for our problem is, how much is your down payment? All right, so again, we're using the percent equation approach. We know our percentage, it's 20%. So that 20% is what we would substitute for the any percent part of our percent equation. What is our whole? Well, our whole is the total price of the car, which is $13,000, and they told us that too. So we know what our whole is. But they're asking for the down payment. Well, that must be the part that the 20% represents, right? The amount that is the actual down payment. So we go ahead and sub in 20% for our any percent in our equation, and 13,000 for our whole in our equation, and then we prepare to go ahead and solve for the part. It's always useful to do so by turning your percent into a decimal and then multiplying it by your whole, which is what that dot requires in the equation. But if you have a calculator that has a percent symbol, then you don't have to do that, okay? You can just put in 20% times 13,000 and you will get 2,600 as your answer. Or if you don't have a percent button on your calculator, you can go ahead and turn it into a decimal, 0.20 times 13,000. And you'll still get the same answer of $2,600. So you have to put $2,600 down on the day that you purchase your vehicle that is worth a total of $13,000. Okay? Let's look at problem number 2. So here in problem number 1, it was the part that was missing, okay? In problem number 2, it's going to be a different portion of our percent equation that we have to solve for, okay? So problem number 2 says that 162 seniors, which is 90% of the senior class, are going on the class trip. How many seniors are there at the school? In other words, how many total seniors are there? We know that only 162 are attending the class trip and that represents 90% of the senior class. We want to know what is the entirety of the senior class, right? How many seniors are there? Well, let's see. 162 represents our part, and we've been told that that part is 90% of the entire senior class, but we don't know the whole. We don't know the total number of seniors. So we go ahead and sub in the parts into our percent equation that we do have. We know our percent is 90%. We don't know what our whole is, but we do know that the part that 90% is 162. Now we're going to solve for the whole, okay? The rules of equations are isolate the thing you're solving for. So we have to get rid of this 90%. As you can see, I went ahead and converted it into its decimal form of 0.90. And then because 0.90 is being multiplied by the thing I don't know, I do the opposite, do it on both sides to solve for it. So the opposite is to divide by 0.90 on both sides of the equal sign. And therefore, that means that my whole is equal to the 162 seniors that are on the class trip divided by the 0.90, which if you go ahead and put that into your calculator means that the whole is equal to 180, or there is a total of 180 seniors, 90% of whom are attending the senior class trip, which means 162 seniors are attending the senior class trip. Okay, so in this scenario, we were solving for the whole. We had the percent, we had the part, but it was the whole that we were looking for. Okay, finally, in scenario number 3, all right, it says Susan scored 48 points on a test that had a total of 60 points available. What percent did she get correct? In other words, what was her grade, right? What was her percent grade? Once again, here is our percent equation. We don't know the percent. That's the part we need to find, right? But we do know the part. She got 48 points. We do know the whole. There was a total of 60 points available. We don't know the percent. So we go ahead and sub in the parts we do know into our percent equation. 60 points being our whole, 48 points being our part, and then we proceed to solve this equation for what we don't know, which is the percent that she got correct. Once again, that percent is being multiplied by 60, so to solve for that percent or to isolate the part that I don't know in my equation, I must do the opposite and do it on both sides. So the opposite of multiplying by 60 is to divide by 60, and we do it on both sides of the equation. This cancels out, of course, telling me that my percent is equal to 48 divided by 60, which if you put into your calculator, you get as 0.8. That is not your percent. In order for that to be a percent, you must now take that decimal and convert it into a percent, because that's what we're looking for. And if you recall from our earlier conversation, how do we convert a decimal into a percent? Multiplied by 100, right? So we multiplied by 100, and now we know that she got an 80% or 80% of her test correct when she scored 48 points out of a total of 60 points available. Now, there are 2 other methods you can use other than using the percent equation. And method number 2 is the grid approach. Now, I am only going to repeat the first problem of the purchasing of the vehicle with this new approach so that you can see how it's used, and then you could apply it to any one of the other 2 problems as well. Or if you look in your textbook, they walk you through the solutions to all 3 of the basic problems that we just finished looking at when we were using the percent equation approach. So method number 2 is the grid approach, where we're basically using that 100 square that we've been using throughout chapter 7 to talk about fractions and decimals, okay? So here's our 100 square, which represents our whole. So this 100 square is representing our whole $13,000, which is the total price of the vehicle that we're purchasing for that problem A that we used, example A that we used in part A, right? Now, the dealership requires that we put down 20%, so the highlighted version here, the highlighted part here on our 100 square represents that 20% that we have to put down. That 20% is equal to 20 squares, right? Which is the part, okay? And we know that 20% is our percent. And this whole square, which is made up of 100, equals our whole $13,000 price, okay? Now, before we can find out what does the 20% represent for this problem, you need to talk about in terms of squares. So we know that 13,000 is equal to 100 squares. What we need to know is how much money is each square equal to, because we know that 20 squares represents 20%. So how do we do that? Well, you just go 13,000 divided by 100 means that $130 is equal to 1 square. So now we know that each square in this scenario using our grid approach represents $130. Well, we know that 20% means we need 20 squares. So if you take $130 and you multiply by the 20 squares, you get $2,600, which is exactly what our 20% of 13,000 is, as you recall from when we used the percent equation approach to solve this very same problem. Okay. Lastly, your book would like to talk about the proportion approach, which is also a favorite. I don't see a lot of you choosing the grid approach to discuss this type of problem, but it is a good tool to have in your teaching toolbox because, as you know, sometimes it's really important to make concepts concrete and visual when you're teaching them for the first time to elementary school students. But I think that most of you will either opt for using the the percent equation approach or the proportion approach, because they're both pretty easy and efficient methods for solving percent problems, okay? So we can use the proportion approach because a percent can be written as a ratio, right? Something out of 100. And we can make ratios equivalent to each other, and that means that we're solving proportions, and that is, as you recall, from our discussion in proportions previously in this chapter, solving proportions is a really easy way to solve for something that we're looking for, right? So the way you set up these proportions is always part to the whole. So we know that we need to know the down payment for the 13,000. That is the part out of the whole of the 13,000. And we already know that we're talking about 20%, which can also be written as 20 being the part and 100% being the whole. So we set up our proportion as down payment is to $13,000 as 20 is to 100. And then using our cross product to help us use proportions to solve, we go ahead and say down payment, or X, times 100 is equal to 13,000 times 20. So we have X times 100 is equal to 260,000. And then we want to solve for X because X represents our down payment, or the part we don't know, right? So we go ahead and divide by 100 on this side and divide by 100 on this side. And that leaves us with X is equal to $2,600, which is the same answer that we've already achieved using both the grid square method and the percent equation method. All right, with that, ladies and gentlemen, we have completed section 7.4. I'm going to go ahead and stop sharing my screen now. Okay, so I hope that these notes allow you to better understand this section. The homework assignment is listed on the assignment box / Dropbox. We're doing the same thing as we did for section 7.3. Your notes, your video, and the Dropbox are all on the same link. So the same link that you access your notes from and you access your video from is where you also turn in your homework. The homework for this section is going to be homework number 19. It's found on page 292 to 293. You'll be doing problems number 1 through 10 although you will skip number 9. And for any problems having multiple parts, just complete parts A through C. All right, have a wonderful day. And again, this homework assignment will be due Friday, immediately before our live session, which begins at 1. So this homework assignment, I believe the Dropbox will close at 12:30 on Friday morning, or 12:30 on Friday afternoon. All right, bye, take care.